NH3 donate pair of electron, so it is base, and BF3 will accept that pair of electron, so it is an acid. So this is Lewis theory of acids and bases. If we take the square of it, 1.2 into 1.2, that is 1.2 square, it will be 1.44. The composition of the reaction mixture, that is the concentration of A and concentration of B as well as concentration of C, is equal to 3 into 10 to the power minus 4. Hello everyone, this is Ambli Unnikrishnan from the Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysore. Last session, we discussed about what are electrolytes and the different types of electrolytes, and then Arrhenius theory of acids and bases, Bronsted-Lowry theory of acids and bases, as well as there is one more theory which is Lewis theory of acids and bases. Right, in detail, we discussed about Arrhenius theory of acids and bases, in which acids are those substances which can donate H plus ions or else which releases H plus ions, and bases are the substances which donate or release OH minus ions, right? And according to Bronsted-Lowry theory of acids and bases, acids are those substances which can donate H plus ions, and bases are the substances which can accept H plus ions, right? So this was on the basis of H plus as well as OH minus ions. The second theory, Bronsted-Lowry theory, was only based on H plus ions, right? And then we studied how to identify conjugate acid and conjugate base pair, right? And conjugate bases for acid as well as conjugate acids for bases, right? As well as what are amphoteric substances also we discussed in the last session. So in today's session, we are going to study about the third theory, that is Lewis theory of acids and bases, and thereby we'll solve some problems based on what we have discussed till now, right? Okay, so moving on to the next theory, that is Lewis theory of acids and bases. So till now, from Arrhenius theory and Bronsted-Lowry theory, we have only discussed on basis of H plus ions and OH minus ions, right? Now we are not going to discuss based on H plus and OH minus ions. It is based on the electrons, right? So according to Lewis theory, acids are those substances which can accept electrons, and bases are those substances which can donate electrons, right? So let's see, according to this theory, acids are substances which accept pair of electrons, okay? They accept pair of electrons, and bases are the substances which donate pair of electrons. So you can remember in this way, acids, it starts from A, right? Acids, what it will do? It will accept electrons, right? So you can remember in this way, A and A. Acids will accept electron, bases will donate electron, right? So for example, we are seeing the reaction between BF3 and NH3, ammonia. So as you can see here, on ammonia, there is a lone pair of electron. So what does that mean? In ammonia, the nitrogen is ready to donate the electrons. So what happens? It is ready to donate the electrons means it is acting as a base, right? So it is a Lewis base. And what about BF3? BF3 is in shortage of electrons, right? So it is ready to accept those electrons. So what happens now? This electron will be shared between BF3 and NH3, right? So in this case, BF3 is ready to accept, so it is a Lewis acid, and ammonia is ready to donate its electron, so it is a Lewis base, right? So in this example, NH3 donate pair of electron, so it is base, and BF3 will accept that pair of electron, so it is an acid. So this is Lewis theory of acids and bases. So I hope the three theories are clear for you. That is Arrhenius theory of acids and bases, Bronsted-Lowry of theory of acids and bases, and the last one is Lewis theory of acids and bases. Now let's do some problems based on the concepts that we have covered till now, right? So let's move on to the first one. The following concentration were obtained for the formation of ammonia from nitrogen and hydrogen at equilibrium at 500 Kelvin. So the concentration of nitrogen, concentration of hydrogen, and concentration of ammonia is given here. What is that we have to calculate? Calculate the equilibrium constant. So we have to calculate equilibrium constant. That means Kc we have to calculate, right? What is Kc? We have to calculate. So the equation is not given here, but it is written that it's the formation of ammonia from nitrogen and hydrogen. That means what is the equation? Nitrogen and hydrogen will combine to form ammonia, right? Okay. So first of all, is this a balanced equation? No, right? Okay. So it is 3 here and 2 here. Now, is it a balanced chemical equation? Yes, right? 2 nitrogen atoms here, 2 nitrogen atoms here, 6 hydrogen and 6 hydrogen. So this is balanced now. So now what is the equation that we have studied to calculate the equilibrium constant? It is Kc is equal to molar concentration or product of molar concentration of the products raised to the power which is equal to their stoichiometric coefficient divided by the product of the molar concentration of the reactants raised to the power which is equal to their stoichiometric coefficient. So in here, what is the product? It is ammonia, right? So the molar concentration of ammonia raised to the power which is equal to the stoichiometric coefficient or number of moles. It is 2. So ammonia raised to 2, right? And divided by which are the reactants? Nitrogen. Okay, so as the coefficient is 1, we do not write anything here, and then hydrogen raised to the power 3. Okay, and the concentration is given here. You just have to substitute the values here. So what is the concentration of ammonia? It is given as 1.2 into 10 to the power minus 2 divided by concentration of nitrogen 1.5 into 10 to the power minus 2 into concentration of hydrogen is given as 3 into 10 to the power minus 2. And what do you have to do here? See here, it is hydrogen to the cube, right? So here cube, and ammonia also, it is concentration to the power 2. So here also to the power 2. That is square we have to do. I hope it is clear. So if we take the square of it, 1.2 into 1.2, that is 1.2 square, it will be 1.44, okay, into 10 to the power minus 2 square, right? So that becomes into 10 to the power minus 4, 10 to the power minus 2 square. Okay, that is 2 into minus 2, it will become minus 4, divided by 1.5 into 10 to the power minus 2, 1.5 into 10 to the power minus 2 into, now this whole thing cube it is. So what is 3 cube? It is 27 into 10 to the power minus 2 whole cube, right? 10 to the power minus 2 cube will be 3 into 2, that is 6, that is 10 to the power minus 6 it will be. So I hope it is clear, right? Now we are going to calculate this 1.44 into 10 to the power minus 4, it's in the numerator. In denominator you have 1.5 and 27. You can multiply those two and keep the 10 to the powers together. So it will be 1.44 into 10 to the power minus 4 divided by 1.5 into 27 will give you 40.5 into, you have 10 to the power minus 2 here, 10 to the power minus 6 here, which will make 10 to the power minus 8. Right? Now, what do we do with the 10 to the powers? We can take this one to the numerator. So, in the denominator, it is 10 to the power minus 8 means if it comes to the numerator, it will be 10 to the power 8. Right? It will become positive. So, what happens then? It will become plus 8 here. Plus 8 minus 4 is plus 4 itself, right? So what is that? You are going to get 1.44 divided by 40.5 into 10 to the power 4, right? This was taken upside. Now what we have to do? We have to do 1.44 divided by 40.5, which is equal to 0.03356 into 10 to the power 4, okay? So instead of keeping it like this, what do? We have to move this 2 points to the right because the n value will come in the, yes, the range from 0 to 9, right? So what happens? We are going to move it 2 places to the right. So if we are moving the decimal point 2 places to the right, what happens to the power? Yes, it will be in the negative. So 2 places to the right means it will be minus 2 on the power, right? So it will be minus 2 here, which will become 3.35 into 10 to the power 2. So that is the equilibrium constant. Okay, as it is a constant, no units will be written there. Moving on to the next question. At equilibrium, the concentration of nitrogen is given, oxygen is given, and nitrogen oxide is given in a sealed vessel at 800 Kelvin. What will be the Kc for the reaction? So here the reaction is already given, N2 plus O2 giving 2NO. Okay, so this is already a balanced reaction. We have to calculate Kc. Again, it's in the same way. What is the molar concentration of NO raised to the power 2, right? Raised to the power 2 divided by nitrogen concentration into oxygen concentration. As there are no stoichiometric coefficients here, we'll leave it as it is, right? Now, what is the molar concentration of nitrogen oxide? It is 2.8 into 10 to the power minus 3 whole square, right? Whole to the power 2 divided by, what is the concentration of nitrogen? It is 3 into 10 to the power minus 2. And what is the concentration of oxygen? It is 4.2 into 10 to the power minus 3. So till here I hope it is clear. We substituted the values. So now we have to take the square of it. That is 2.8 into 2.8 will give you 7.84 into 10 to the power minus 3. Square will be 3 into 2, that is 6. It will give you 10 to the power minus 6 divided by. Now what is that we have to do here? 3 into 4.2 we can do. Right. So 3 into 4.2 will give you 12.6 and 10 to the power minus 2 into 10 to the power minus 3 will give you 10 to the power minus 5. Okay. So what happens if we are taking it to the numerator? This 10 to the power minus 5 will become 10 to the power 5. Right. So it will be 7.84 divided by 12.6 into 10 to the power minus 1. Right. Minus 6 plus 5 will give you minus 1. Right. So if you are dividing 7.84 divided by 12.6, you will get 0.622 into 10 to the power minus 1. So 10 to the power minus 1. So if you are moving the decimal point towards the right, what happens? Again, minus 1 will come in the power. So it will be 6.22 into 10 to the power minus 2. So this will be the equilibrium constant. Okay. So now moving on to the next one. PCl5, PCl3 and Cl2 are at equilibrium at 500 Kelvin and having concentration 1.59 and 1.59 and 1.41 molar. Calculate the Kc for the reaction. So the same method you have to follow here also. The equation is already given for you. Kc will be the concentration of PCl3. Now the products are PCl3 and Cl2, right? PCl3 into Cl2 divided by PCl5. So as you can see here, it's already a balanced equation and there are no stoichiometric coefficients given here. So what happens? You just have to write it in this form. Right. Now, what is the molar concentration of PCl3? It is 1.59. What is the molar concentration of Cl2? It is given as again 1.59. And what is the molar concentration of PCl5? It is 1.41. Right. I hope it is clear. That is, we just substituted the values of molar concentration. So now if you are doing this calculation, we get the answer as 1.79, which is the value for Kc. Now moving on to the next question. The value of Kc for the reaction 2A giving B plus C is 2 into 10 to the power minus 3. The value of Kc is already given, right? At a given time, the composition of the reaction mixture, that is the concentration of A and concentration of B as well as concentration of C is equal to 3 into 10 to the power minus 4. In which direction will the reaction proceed? So it's a different type of question. In which direction will the reaction proceed? So how can you identify in which direction the reaction will proceed? For that, you have to calculate something. What is that? It is QC, right? Reaction quotient you have to calculate, right? So reaction quotient and equilibrium constant, what is the difference between them? A reaction quotient can be in any concentration, right? And equilibrium constant will be only applicable in the equilibrium concentration, right? Okay. So the equilibrium constant is already given Kc, right? We have to calculate QC and then we have to compare it with Kc, right? If QC is greater than Kc, we can say that the reaction is proceeding in the backward direction. And if QC is less than Kc, the reaction is proceeding in the forward direction. And if QC and Kc are equal, we can say that the reaction is at equilibrium, right? So for that, we have to first calculate what is the value of QC, right? So the QC, again, it was the same equation as that of Kc, but in another concentration, right? So what are the reactants and products here? Product is B, right? So B and C are the products, that is product of the molar concentration of them divided by 2A, that is A to the power 2, right? This number of moles or stoichiometric coefficient will come in the power, right? So now what we have to do, we have to substitute the concentration, which is the same, right? So what is the concentration of B? It is 3 into 10 to the power minus 4. What is the concentration of C? It is again 3 into 10 to the power minus 4 divided by, what is the concentration of A? It is also 3 into 10 to the power minus 4 raised to 2, right? This 2 will come there. So what does that mean? It is square means again it's 2 times. The same thing is the numerator as well. So this and this will get cancelled, right? 2 are there in the numerator and square is there in the denominator, means it will get cancelled, which will give you the value 1, right? Which will give you the value 1. So QC is 1 we calculated. Now what is the Kc value? Kc value is already given 2 into 10 to the power minus 3. So it is 10 to the power minus 3. What does that mean? Yes, it is a smaller value than 1, right? 10 to the power minus 3 means it's a smaller value than 1. So what does that indicate you? Qc will be greater than Kc. So we have already studied this. If reaction quotient is greater than the equilibrium constant, the reaction will proceed in the reverse direction. Reverse direction. Okay, reverse direction means in this example what you can see, B and C will be the reactants. They will combine and form A, right? 2 moles of A. So this reaction will be preferred. Okay, so this is how you have to calculate such type of equation. So in which direction, how can you identify in which direction the reaction will proceed? By using the reaction quotient, which you can calculate with the same equation as that of equilibrium constant, right? And we have to compare the value of Qc and Kc. So as here it is Qc which is greater than Kc, we can say that the reaction will proceed in the backward direction. So I hope the concepts are clear. So in the next session, we are going to study about ionization of acids and bases. So I hope the concepts that we have covered in this session is clear for you. So that's all for today. Thank you.